Good morning, everybody. As you know, we have another virtual day because it's a snow day. So while you have all of the notes that I plan to cover, I decided that I would record a brief video to make sure you get the main points. The first class from Tuesday, I gave you some notes that were basically an introduction to probability and had you read a paper by Jack Good, which talked about many different kinds of probability. Uh, Today, I want to narrow that down, so I want to introduce probability, and I also want to talk about the review of set theory. Mostly, you will do this by reading the papers, but I do have the set of notes displayed, and I also wanted to show you that the slides, which are created by a tool called Beamer, actually have some navigation capabilities built in. So if you look at the bottom of the slide, you'll see a little single page, and if you click on the arrows next to it, you can advance through, or you can go backwards, and then the others take you from section to section and things like that. And you can play with those and see how they work, but that's available on all of the slides. So I'll go back to the beginning. And we start out by a definition of what probability theory is, and we talk about the existence of randomness in our lives. Essentially, probability is a framework for analyzing random events. And so what we need to do is to talk a little bit about this. So random phenomena are events and experiments whose outcomes we can't predict with certainty. In other words, most of the things that we deal with in science and engineering. Here we talk about a coin flip, and we'll talk about coin flipping a lot through the early part of the course. So I talk about some more things about randomness, and again, you can read the slide, but essentially, randomness enables us to express what we don't know. I here focus on two of the definitions of probability. One is the statistical version, where we talk about the relative frequency of events. The other one is where we talk about probability is the degree of belief that something is going to happen. We call these two kinds of probability the frequency approach or the classical approach. We call the degree of belief version a Bayesian after Thomas Bayes, Bayes, who first put forward these ideas, though the version that we use was essentially formulated by Laplace and people who came later. But we'll find that both of these are useful, and fortunately, we can use the same mathematics to describe both, and it often doesn't matter which version of the probability we're actually thinking we're using. So then the next slide talks a bit more about that. And give some examples. In fact, the first example is about a communication system where a phone transmits one sequence, the receiver receives a different sequence, and basically then we need to figure out how to minimize errors like that in communication systems, and we introduce the idea of noise. Essentially, probability is used to analyze noise, and it's also used for error correcting schemes, which are things that we'll talk about later. One of the mathematical notations that we're going to use a lot is the notion of set theory. And when we are using set theory, to describe probability. It's actually what we're actually doing is something called measure theory. We're not going to make use of that idea very much, but I just want to note it in passing. And here I review the basic definition of sets and symbols. And so you need to know what elements are and what subsets mean, and what belonging means, and or how it's denoted, and how not belonging is denoted. We deal with some sets over and over again: natural numbers, integers, rational numbers, complex numbers. So those are things that you'll certainly need to know what we mean by. We'll need to know about subsets and supersets, and you'll need to know what we mean by the universal set. The universal set in probability coincides with the idea of sample space in an experiment. The sample space is simply a collective a description of all of the possible outcomes that could happen in an experiment. You also need to know what a null set is. Venn diagrams are used to visualize relationships between sets, and we will make use of Venn diagrams. And just some examples. You'll need to recall what the union of a set is, and the details are here. You'll need to know what the intersection of sets are, and the details are also on this slide. You'll need to know what the complement of a set is, and you'll need to be able to do a few operations like subtraction, and I just show you in principle what it is here. You'll need to know what mutually exclusive or disjoint sets are. We'll talk about partitions of sets. We'll use some theorems, and I'll talk about these two theorems when we first use them. I'm just collecting them on this slide. We'll need to know what the Cartesian product of sets is. Again, I'll go through this when we actually make use of it. And you'll need to know about the multiplication principle for sets. Again, I'll go through this when we actually use it. And cardinality, which is a measure of the size of the set, is something you'll need to know. And the inclusion-exclusion principle is something we'll use later. Then we'll also need to extend cardinality to infinite sets, and we'll need to know the difference between countable and uncountable sets. And then there are a few theorems which we'll make use of, and the functions are basically mappings between a domain and a codomain, and that's something that you need to be familiar with. This is it denoted theoretically. We'll talk about it more when we actually make use of it. So. Lecture 2 is an introduction to probability, and it's an overview of set theory. And basically, on this set of slides, I have pulled out the results that we will make use of during the course of the semester. There are more results in Pichronik's chapter, but these are the ones that we will actually make use of. If I actually make use of something else, I'll obviously introduce it when we do, but I wanted to start out by pointing out to you the pieces to concentrate on when you're reading about this material and internalizing it. So having done that, we are now ready to get started on actually making use of some of these ideas. And this will occur in the next class on Tuesday and in Thursday's class of next week. And at that point, I will start assigning some homework problems. We probably would have started that today if we were actually in class, but since we are not, and since I really want to do that in person, I will do that next Tuesday. So look forward to seeing you next week. And just a reminder, all of our classes will actually be in room 212C of the Conway Corporation Center for Sciences, rather than in the big classroom. And I anticipate that I'll post the outline notes for Tuesday's class before Tuesday's class, but we will really get things rolling then. Having a snow week and the first real week of class is the worst possible time, but we do what we have to do. Stay warm, stay safe, and I will see you next week.